So in this video, I'm gonna give a brief introduction to MATLAB. And MATLAB stands for Matrix Laboratory. And it's first, it was a mathematic-based computer-aided calculation program, but later on they extended it into different fields and built up the Simulink environment for it, which was very helpful for different majors. Two main functions, two main things that we use in MATLAB is first, I think you are already familiar with scripts and M files, previously named M files, and they are saved in .m file format. And now you can use as scripts. You can write programs with the scripts here. And this is the Simulink that we are going to explain today. Simulink is it's an environment that is based on schematics and visual of the components. You can see the components visually, and it's a very useful and user-friendly environment. You can open up the Simulink from the main page of home page of MATLAB here, Simulink. And this is the 2020B version that I'm using, and it's very similar to other versions. For example, I have 2017B here. It's very similar. So I'm gonna use the 2020B version, which is more updated. Then you will see the library here. Although you can just search for components by double clicking in these versions, you can just double click and search, for example, scope, and it will bring scope from, for example, Sinks, Simulink Sinks, HDL coder, from different libraries wherever they have scopes. And if any component named with scope, it will bring up for you. But I'm gonna use the library browser for now. Once you click on library browser, you will find different libraries here and toolboxes. The first one is the Simulink one, which is commonly used blocks. It starts with commonly used blocks, and they are common between different libraries. You can use these blocks and components in all the toolboxes and libraries. Commonly used blocks contain usually scope and, for example, in, out for subsystems, constant, bus detector, demultiplexer, and multiplexer. We have continuous blocks here that take, for example, derivative of a function or signal, and integrator. We have continuous blocks here, and we have discrete, discontinuous, discrete. For example, you will find unit delay here, which we will use in our course later, and logic operators, math operations. These are very commonly used blocks and libraries that I'm just briefly introducing. And signal routing, usually we use signal routing, sinks, and sources. For example, you can find sine wave and step function here. And in this course, we have other libraries, professional libraries for different majors and fields. And we are going to use Simscape in this course. Simscape library is also, we have different blocks here. and parts. We will use the electrical part. In electrical part, we will also use the specialized power systems. Simscape is usually used for electrical, and in electrical we have different libraries for power system, motor drives, and power electronics. And for power electronics and motor drives, usually we use specialized power systems, fundamental blocks part. So the first thing that we need to add to our simulations, it's the power GUI, which is usually is needed when you are adding components from these libraries. It is somehow the solver of our simulation. Then we have I'll start with electrical sources here. We will have 3-phase and single-phase sources, DC, AC controlled and uncontrolled. If you click on, when you add, you can just right click and add to your block to your model, which I haven't named my model and saved it. It's untitled. So if you add this, then you will find it in your model. It comes to the middle of your model. Then you can move them to wherever you like in your model. And if you double click, you can find the parameters and adjust them as you wish. Then backspace goes to page before. And we have elements here. It's the passive elements and very basic elements that we have. For we will use the most commonly the RLC branches, series, and we also have parallel RLC branches here. Parallel and series RLC branches. For example, if you need a resistor, you have to add a series or parallel RLC branch. The difference between load and branch is that you cannot change I'll add one series, and then let's compare it here. It's a series RLC branch. For example, I need a resistor, so I will put it on an R branch and adjust, for example, 100 ohms, or you can even type, for example, 2 times 50. It is 100. It will do the same for you. But here, if you double click on the load, RLC load, you cannot change it to a pure R value. So most probably we are going to use RLC branches in this course, parallel or series. Let's go back to library. We have the ground here, which is in most cases we need a reference point. It is ground for us. And we will have interface elements, machines, which are motors and machines here, measurements, current measurement, and voltage measurement. We are going to use it a lot. And power electronic devices. We have for example, full bridge converter here. It's ready to use, or you can build up your own full bridge converter by we use IGBT diodes with the diode already in it, or you can use IGBT and a single diode. And we have ideal switch here, thyristors, and MOSFETs. That's it for introduction of the libraries here. Then I'm gonna just show the wiring of a simple circuit here. For example, I have a resistor and a source here. I'm gonna configure my simulation. Right click and go to model, configure parameters. The simulation stop time that is shown here at the top is also configured from here. I need to simulate this circuit, for example, half seconds. And then you can choose the solver. Is it a discrete circuit or continuous? It has continuous things, or you need to, most probably it's discrete for our applications, power electronic applications. It's most probably discrete. You need to put it on discrete or choose a solver, discrete solver here, and fixed step size. Then you can put your step size here, define it, for example, 1e -5. This should be my step size. It should be small enough to catch all the transients myself. Then on Power GUI, you have to put it on discrete. Again, here it's your sample time for the whole circuit. You can adjust it. It affects the simulation time a lot. So these parameters, the step simulation sample time and simulation step time step, they are very important, and if you choose very small, then your simulation will, if you choose a large value, then it won't catch the details, and if you choose very small values, then it will take a longer time to simulate a circuit. And for wiring, let me just bring more. For copying an element, you can just simply go over the element, right click, drag and drop, and just leave the right click. Then it will copy the element. You can also copy the element by just copying and pasting. It will do the same. For connecting, it's just, you just click, left click and drag and connect it to the other one. It's very easy for MATLAB. Also, you can just click and press Control and click on the other component, and it will connect it automatically. Then another thing that you need to know about MATLAB Simulink is that, for example, let me bring a measurement, a current measurement that I need here. For example, I'm going to measure the current here and do this. So if you pay attention, there are some points that are square and some points that are like triangle shape. The square points connect together, but the triangle shape won't connect to a square point. The square points are electrical signals, and triangle points usually indicate that this is a data. The signal is converted to a data that we can just see. If you want to see this data, you will need to have a scope. Scopes usually are used to show data. That's why it's in triangular shape, and it shows that it's output and this is input. So MATLAB schematic, Simulink schematics shows also what needs to be connected to which component, and its routing is very user-friendly. You can also give names here. For example, change the name of RLC to R. Just give a name R, or then I just, for example, this root, you can give names here for roots too, or just double click and give some explanations. This is an example for our course, for example. Then here you have very easy to work with. Change the font size and its color. So we have done the routing and set up our circuit, did the preferences and settings, and we are almost ready to start building up more complicated circuits now.